In the next objection, section 6.5, is the arguments from disabilities. Now, Turing's word disability might throw you a bit. Really, what he means are inabilities, right? So, we use this word disability in a different way than Turing is using it. So think inabilities. And how does that go? Well, and you often hear this. You'll hear people say things like, "Well, you can make a machine that does a variety of things. Yeah, the machines finally can play chess, but it can't do something else. It can't do so. You can make machines do all kinds of things, but not X. What could X be? Well, you can fill it in with a variety of things. During you can have a look. He lists a bunch of things that could be filled in for X. Like, well, you can make a machine that plays chess, but it can't be resourceful. You can make a machine that plays chess, but it can't be beautiful. Or you can't make a machine can't be friendly. It can't learn from experience. Well, he'll talk about that machine learning in a bit. You can't make a computer that's self-reflective. You can't make a computer. You can make a computer that plays chess, but you can't make a computer that's truly creative, and so on and so on and so on. And he says, okay, now what supports these inability? And I'm going to use the term inability. He says disability, but these inability claims that a computer can't do. What supports this? He says nothing really, except maybe that people see machines doing things and then they draw conclusions about what they can never do or can't do. And he said, this is just induction, but it's a dubious kind in the sense that we move from observed machines that are very narrow, and if you look around at the machines around you, like they tend to be very narrow. They're very good at doing one particular thing, and machines are much more advanced than they used to be, but nonetheless, their functions tend to be quite narrow. And so what Turing is saying is that we look at the narrowness of them and then make an inference to a necessary narrowness. So an observed regularity of narrowness, that's an empirical generality. We then infer that it's a logical necessity. And he said this, of course, is debatable. So observed inability to an intrinsic or necessary inability. And of course, that's not exactly a good inference. You could argue against it in a variety of ways. Turing also raises, but he just sort of lets it go, that various inabilities could be linked, so you could have a look at that. He said, maybe the inability for machines to enjoy strawberries and cream could be contributing, could be linked up to an inability to express friendship. So have a look at that. He doesn't really go very far with that comment, but nonetheless, it's interesting. He then considers what is a standard point of machines. We said, well, machines are really unlike this. This is a common argument. You'll hear this, that machines are really unlike us in that they can't make mistakes. We make mistakes. So this is like turning our ability to make mistakes into some kind of virtue, right? Well, that's what's really human. To err is human, right? To forgive is divine. So this notion of, well, machines aren't like us because they can't make mistakes. And Turing gets a little defensive. He says, so what, right? Are machines the worst for their inability to make mistakes? That's kind of odd. Maybe that's a good thing. But that's not his full reply. And that doesn't seem to be his serious reply. He says something like, you might argue that a machine can't make errors, so you could pick it out in an imitation game quite easily. Basically, if you were trying to pick the computer out, you would ask questions that involve, let's say, quick calculations of large sums. Humans, not many people can do that. That's the exception, right? That's pretty rare if you give a human person, two incredibly large numbers and say, I want the sum of that, and no pen or paper, no calculators or whatever, just do it. Most people can't do that, and if they're any good at it, it's pretty rare, and we often make mistakes, even adding up small numbers and things like that. So but humans can't make those, or machines don't make those mistakes. So you could basically you could find the machine out by asking those kinds of questions. And Turing says, well, so what? Program the machine to give out false answers. Now Turing says, yes, true. If you were a clever interrogator, remember, you're the one in the room. You could maybe find that there is a pattern to the machine's false answers, whereas a human would give kind of randomized false answers. The machine might give a pattern of false answers where, let's say, you would notice that it was always off by 10% or over by 10 or something. You notice that its errors follow a pattern. And as the computer programmers say, it looks canned. It looks like it's been prepackaged, and you say, there's the computer and you'd spot it in the imitation game. Turing thinks that there's responses to this as well. But he doesn't really dig into it. He just says, I want to separate what he calls the functioning errors and conclusion errors. And he thinks that in the abstract, yes, the machines can't have functioning errors. And he says, in this sense that machines, like when we think about them, they're idealized, at least in his discussion, and they don't make those kinds of errors. But again, he says, conclusion errors are a result when meaning is attached to the outputs of the machine, and he sees no reason why, although he doesn't, admittedly, he doesn't really argue or clarify this, but he just sees no reason why machines can't make those kinds of errors. He thinks that machines will, and he postulates this in the future, that they will learn through experience, they will make mistakes, and so in that sense, he thinks that that's also an answer to machines when we, in this thing, well, machines can't be objects of their own thought. He thinks that they're not far away from machine learning. Now, remember, this is 1950, so machine learning was, pretty speculative. We talk about machine learning all the time today. So the question is, but is that enough to make a machine self-conscious or the object of its own thoughts because it modifies its own programs on the basis of earlier data and then its results, and then it changes its own programming? Is that true learning? Well, Turing suggests that he thinks it is, and so that's a way around this problem of you can get a machine to do X, Y, or you can get a machine to do a bunch of things, but you can't get it to learn. He thinks, yeah, we're probably on the edge of that. But of course, the response to that is learning just rewriting software? Is that really all humans are doing? Is that the same way? We'll see. John Searle will object to a lot of this kind of stuff in his paper, but that's for another video. But Turing's point is that he sees no reason to deny the ability of computers to make errors when you're talking about conclusion errors. But ideally, no, they don't. But you could program that one to make all kinds of mistakes. Would that satisfy? Turing thinks so. It's still an open question. In section 6.6, the Lady Lovelace objection. What's that? Well, this is a version. Anyways, there's a bit of a subtlety going on here, but roughly it's the old creativity problem. So in one sense, it's this one. You can make machines that do all kinds of things, but you can't make a computer that's creative, right? And so ultimately, machines are all parasites on us, right? There's no such thing as a creative machine. It's whatever's put in. There's the creative part. The machine itself is not creative, right? So goes this argument. Okay, so Turing leaps to the defense of the machines in this sense. He says, okay, fine, but what exactly is creativity? What are we thinking about? What do we mean, right? So now he dives into the philosophy stuff because it is a question of what do you mean by creativity, right? And he thinks we've got a mythology of creativity. And what do we really mean? Sometimes we say there's really nothing new under the sun, so nobody's really creative. That's one way to go. You can say, well, yeah, computers aren't creative, and neither are we, so big deal. You could run that line, or you could take a softer line, like something like this, and you could say, take Joe. We say Joe is creative. What do we really mean by that? right? Turing says, are we really, when we say Joe is creative, are we not just overlooking a number of things in a romanticized, as we romanticize the notion of creativity? For instance, people like to say, "Oh, Einstein was so creative." Yeah, sure he was, but he was also very well trained, right? He knew a lot of physics to begin with. It's not like the guy didn't know any physics and then bang came up with relativity out of the blue, right? Even the expression out of the blue, like that we tend to romanticize the notion of creativity like it's just ex nihilo. It's like a god. It's just bang, it comes out of nowhere. Turing is saying that when we do that, we're forgetting about, to go back to Joe, the creative guy, that we're overlooking his education, right? And again, back with Einstein, people write about Einstein like he wasn't trained in physics, that he was just this is raging maverick and what? No, he studied a lot. He was a hardworking guy, right? And he spent hours trying to figure out those equations that eventually came down as special relativity, general relativity. There's lots of documentary evidence that he was a super hard worker. Yeah, he's super smart, and he was also super hard working. We tend to romanticize the super smart stuff, get rid of all the boring hard work stuff, and just say, look, man, he just imagined he was on a light beam, and bang, came up with all this stuff. And we also don't tell the story of there were a number of other scientists that were working in a similar direction, that Einstein was even a little nervous about, that they might beat him to the final formulation of general relativity. So it was a lot of, blood and sweat and toil to get there. It wasn't just boom, like Archimedes in the bath when he just sat in the tub and then went eureka, or Newton just got hit by an apple and then came up with the whole theory of gravity just out of the blue. So Turing is really saying, we got to be careful about that. We attribute some property to ourselves that we don't even have, and then we deny it, and then we say, well, computers will never do that. Well, maybe we don't even either, right? So that's an important notion. We like to tell ourselves stories because we love creativity, but this denies the virtue of hard work, and so if computers are just hardworking entities. We just see the hardworking nature in front of us. It's not romantic, and we romanticize ourselves. So is that what we're really doing? So we should, respect the virtue of working things out, because that's actually what we really do, and that's what computers do. So once again, it brings us closer to the notion of a machine being just like us. It's just without the romance. Now, that's okay. So that's is basically the computers can't be creative. It's not saying anything more than we should really think and pay attention to what we mean when we attribute creativity to ourselves.